this failure modes and effects analysis in this webinar. And the level of details is just at the introductory level so that you get an exposure. What is this all about? And how do we use, where do we use, and what are the challenges when applying this failure modes and effects analysis? It is commonly called FMEA in short form. So in this webinar, I would like to cover the background, historical background behind this failure modes and effects analysis, FMEA, and where does it start, how did it get started, and where we are at the current moment. That will be covered in this current applications, in which industry or what type of industry they are using it quite often. And then there are some shortcomings of this method and their benefits. So we'll cover very quickly on that part. And then we will move into the details of this FMEA process, like what should be the input, what should be the output, and what do you do with the input, and how do you convert into output that is required in this FMEA. And then briefly we'll touch upon that based on my industrial applications, like what are the challenges that we face when we are applying the FMEA, because in theory, many times it appears to be quite simple, but when you start to apply, there are some practical tips that helps. There are some challenges. And at the end, we will just touch upon these typical job roles in the industry, what type of roles or what are the job titles people have. And then at the end, as Shubha mentioned, that we will have a Q&A session in last after this 45 minutes or 40 to 45 minutes. So coming to here, the background, the first coining of this name came from US military in 1949 after the Second World War, because when they were having many missions, so they were experiencing a lot of problems, that why these missions are failing, what are the defects happening, why we cannot do this. Then they came up with a process, what was called failure modes and effects analysis. And that was in 1949. First time it was documented as a form of a procedure, that how do you do this FMEA to prevent these mission failures. So that's what my picture one represents. And then later on, there has been many applications within the US military and then other industries too. NASA used in 1960 when they launched their Apollo mission. And then in 1980, finally, that was a standard was created. And that standard is called 1629A. After that, there have been some modifications of these standards. But in military industry, still people use this standard as a reference whenever they are asking a supplier or manufacturer or designer to create a product for the military use. And all the Airbus or any other industry, even the airlines industry has adopted this one. And later on, this became part of this ISO 9000 and Quality System 9000, or in this automobile industry, that everyone should use this failure modes and effects analysis. And the latest update in this area as an international standard for common industry is from this British standard 60812. And then you have this automotive industry action group, AIAJ, which leads all the car industry. They have sent version 5 handbook also, how to apply these methods. And then there is a German one, which is called VDA, that's about the automobile industry. So the German one, VDA, and this AIAG, they together have published this handbook, which should be followed when you're doing in the automotive industry. And then during this process, some people have called it FMEA and some people have called it FMECA. There is a slight difference in these two. FMEA stands for failure modes and effects analysis, while FMECA stands for failure modes, effects, and criticality analysis. So in military industry, this CA, this criticality analysis is very crucial. Or wherever you are doing the safety analysis, this becomes very important. While FMEA you use as a starting point, and then you extend that FMEA to create your FMECA, where you get into more details of how to do FMECA criticality analysis. So as the picture shows, like it started with the mission system. Then we had many missile launches, and then the Apollo missions, then car industry, and then now every industry, especially the consumer industry, whether it is handsets, mobile phones, base stations, telecom industries, any industry you name it, they use FMEA if they want to create a high quality product, because you look into the failure modes and their effects, and then you do some action to prevent them or to eliminate those problems. So what I want to, it started with the high technology, but now it is used even common general use technology to make a better product. So it has become a general approach in the industry when you're creating a product or creating a process. And manufacturing industry has been using quite a lot for a long time. So number one application that all regulated industries like airlines, aircrafts, any safety related issues, or if you want to get a certificate of any product that you use even in day-to-day use, some of those requirements are that you should submit an FMEA for the specific part that you are supplying. So even the suppliers, when the car manufacturers, when they get some components from their suppliers, they have to submit this FMEA. And when the product is accepted by the authority to be used in the market for the certification license to get it used, then you need to provide those FMEA in some of the cases, not all cases, depending on if it is related to safety or not. So that's from the authority side, where you have to take a permission. And then product design. And when I say product, so anything that you're creating as a hardware, there you need this FMEA to improve the product. And most of the industries, not only automotive, all airlines, all aircraft manufacturing industries, they're very extensive use of this FMEA. And then when you are trying to do manufacturing of a product, like in the medical industry, you have to submit very detailed FMEA. Even if you are doing some syringe, or even if you are doing this, some dose delivery by some mechanism or any medical equipment, you have to submit those. And then services side, what I have seen recently, the financial services that big investment banks do, they are also carrying out FMEA. Even healthcare services in states, it's quite common to carry out this FMEA and the other methods from the quality to improve the process. So it's a very vast application. So in general, it is for the continuous improvement. Wherever the industry is inclined to improve their products better way, so they are using this FMEA. And then risk management, where when you are doing the project risk analysis, product risk analysis, you have to submit this FMEA, or you submit this fault tree analysis. That is another way of doing the risk analysis. So in general, all the industries, they are using it, but extensive usage in aerospace industry, aviation, defense, automotive, medical devices, and consumer electronics. It's a very extensive use of this. After knowing the background applications, so we can just briefly touch on the advantage. The good advantage that it removes or eliminates or mitigates or reduces the fault that can happen in the system, or it eliminates the accidents that can be caused by the system when something fails. Other advantage that industry has experienced is that when you are developing something, then you test it, that is it fit for the purpose or not. But since you are earlier, when you are going to test it, at that time you used to find a fault and then you had to redo the design and then move on. That used to be in many prototypes that you had to test. But being it an expensive process, so people have started to focus a lot on this failure modes and effects analysis so that they can think on what are the possible failures can come and then eliminate in the design before they get the first prototype itself. So many places, earlier they used to have like 4 rounds or 6 rounds of design changes. Now they have come to the stage of just 2 prototypes. By using not only this FMEA, there are other tools people use it. So that's a big advantage because it delay process is eliminated. The root causes to the delay, one of the root causes is eliminated and the cost becomes less. Then customer satisfaction, like if you have been able to eliminate, mitigate, or reduce or decrease those faults that can come into a system which a customer is going to use, if he doesn't experience those problems, definitely their satisfaction level will improve. And then ultimately, I explained this delivery time. You can meet the delivery time. And the service side also, it's quite good because this FMEA later on converted into fault tree, and then you use it a fault diagnosis also. So that makes your faster service to any problem that customer can face. And that customer can have a product or service the way you design it by application of this method during the design. The disadvantages is that it takes quite a lot of time and you need input from various sources. So the mechanical designer, the electronics design, the hardware design, the EMC designer, the all sources of information you need to carry out this work. And one of the disadvantages of what happens in the customer side, like what is the expectation of the customer that comes through the marketing. But when you are doing the design, you provide a different function which may or may not meet the end customer's requirement or expectation from that product, from that service. So sometimes one of the things that people miss is to go back to the marketing again to revalidate your changes in the design based on this FMEA. So these things just we should keep in mind when you are applying the FMEA. So now after this background, applications, advantage, disadvantage, we come to this. What is this FMEA after all? As its name says, the failure modes and effects analysis. So the name itself clarifies that you are looking at the failures and their effects, and you're doing the analysis. That's the crux of this whole process. But there is no authentic international definition. You can define in another way, but the main content is that you are studying the causes and effects of failures to prevent the failures and errors from occurring and reaching the customer. That's the main core or heart of this whole process. So in this process, I mean, some of the textbooks, some of the places people will say that there are 6 types of FMEA or 8 types of FMEA, failure mode and effects analysis. But in general, you should just remember there are two types of, based on the approach, there are 2 types of FMEA. One is the design FMEA, another one is the process FMEA. Now this design FMEA can be concept FMEA or system FMEA. Same way the process FMEA can be at the concept level, at the assembly level, manufacturing side, and system level process FMEA. So when people are doing the design level FMEA, like when you're creating something new, a product, there, if you are in a very early phase of the design, like you're trying to make out which of the 3 concepts or 4 concepts of this design is suitable for the customer. So you do FMEA at that stage itself. And that's what we call it, concept FMEA. And then once you have come to the selected one specific design to carry out this FMEA, then you start the system FMEA. And that system FMEA, there are many ways to apply it. You can start with the system FMEA or the subsystem FMEA or at the component FMEA. But you normally, depending on what is your system, my system can be subsystem to my customer whom I am supplying that component. So this definition is fluid depending on what you are doing. So the system is something that is a component ME can be a system for the component manufacturer or component supplier. Same way as the process FMEA. If you are just doing the assembly, are you doing the assembly of the system or subsystem or component? And then manufacturing side, again, you're manufacturing the system, subsystem, component. An example, you can take your bike or motorcycles or car. Let us say it's a tire we are talking about. So, or in a bicycle, if you're talking about the tire, so the bearing house, if the main manufacturer gets the bearing house, bearing house is a component for the manufacturer, but the company which makes the bearing house, it is a system for that company. So I hope this is clear. Like this system, subsystem component depends on the context of my analysis. It is not defined exactly what is this. The context will change, whether for me it is a system or subsystem or component. These things are very important to understand because that's where we mix up when we start to do FMEA, that what is my scope of study. So in this slide, I'm just listed how do we do this FMEA as a process, like what is the input and what do you do with those input, and then what do you give the output. So as a step one, please make sure that your objective, this FMEA, this analysis is very clear. If it is not clear, because it becomes so huge task that you start to confuse between actually what I was trying to do. And it can go into pages and pages this report, and you will be not able to meet the what the customer wants or what your, when I say customer, uh, for a FMEA engineer, the customer is the design, either will be the design team or will be the manufacturing team. The customer also changes here. So be clear about your objective, what you're trying to achieve, and what is the scope of your work. Like what is a system, what is a subsystem, what is a component for you. And then once that is clarified, then you should, there are many templates available on the internet. You download from there, but you have to customize those templates to meet your objective and the scope of your analysis. So these two things are based on your experience. You negotiate, you figure out what is to be done, what I am trying to achieve, and what will be the suitable template that I should be using. However, there are many software that provide, but those becomes very complex because they do for the all type of industry. And I find it easy to use this Excel template. But depending on your industry, if it is very complex, you may use those softwares. And then as an input, you need something we call it functional block diagram for the system, subsystem, or component. And you need the schematic diagram of the design. These two things are fundamental so that you can look into the system and see what is the input of a subsystem, what is the output of the subsystem. Once you have got those functional block diagrams, I will, in the later slides, you will be getting into more details on this. And then we should be looking at the how those functional blocks can fail. What are the possible way it can fail or potential failure modes? And what are the potential failure causes? Like why it will fail. And then you look at the what will be the effect of that potential failure mode. And that effect can be either at the local or intermediate level or at the end level, at the system level. And then next, so in general, I have listed here 7, but in some of the textbooks, some of the authors say 4 steps, 9 steps, or 5 steps. But basically, it depends on how you define those steps. Like planning, someone says the planning is the first step, where it means that basically you are looking at the objective, the scope, and FMEA template, etc. And then I'm on this after effects of a potential failure mode. These last 2 are the most important, confusing, or weakness of applying the FMEA process. Because to identify the actions to mitigate the severity of the, or how critical is that failure effect, or what will be the extent of damage, and how often this can happen, this probability of occurrence, these are a bit challenging to agree with the team, with the design team or manufacturing team, And there are some way to get out of this, or there's some help on this. So I have listed a few things that can be of interest to you all. Uh, and then once you have done that, define the most important, that you should be able to identify the action based on your analysis. That is the most critical one. And then once you have done the actions agreed with the project, it's a FMEA engineer's responsibility that, depending on the timing, he should revisit again and redo these things, because when the design progresses, the risk scenario, this severity, consequences, and probability changes. These are the last two steps that I have listed here. These are the most common mistakes or common misunderstanding or common weakness that we do as a FMEA engineer or quality engineer or reliability engineer.